There's your homework there. 5 questions, and my bet is you get the answers wrong, all of them. Because, of course, there's information that I've got you haven't. What? Precedence of operators matters, yes, but that's not all. The operators aren't what they seem to be. This is just a sort of taster, in actual fact. It's the end before we start. I think we're more or less coming up to start time, so just let me give you a quick view of the answers, and then we'll get on with the talk itself. And anybody who got the last one right shouldn't be here. They already know too much. Okay. I think I'm about ready to start now. Interesting question. Why would one want to learn a new language? And notice, I didn't say a new computer language, a new language. Well, perhaps you just need it for work. You know, if you're going to go and work in Japan, it's probably a fairly good idea to learn some Japanese. You may think you can survive without, but it's probably a good idea. It may be just fun. I had a great aunt who was teaching herself Russian at the age of 83. No other purpose than just fun. So that's one possibility. You want to improve your skills. Not necessarily just computing skills, but you want to improve your skills. Quite important. And if you're going to go on the job market, of course, it may be fairly vital. Improve your problem solving. How do you look at things? That's actually quite important. I am amazed at how bad some people's problem solving is. On the other hand, I'm amazed at how good some people's are. Or something else. I don't know. People do things for all sorts of reasons. I'll give you something else in this case. Where did this talk start? This talk started with a column I write in CView in which I set a homework challenge to people. And I thought, I'd have a bit of fun this time. Let's give the homework challenge to ChatGPT. And what's more, let's ask it to do it in some arcane language that I know nothing about. So I asked it to do the challenge in APL. And it produced a program that sort of looked like APL. Did it work? I don't know. I hadn't got an APL interpreter or compiler. So out onto the net, and I found an APL compiler produced by a company called Dialog, commercial compiler, which they would give a license to anybody who just wanted to use it for non-commercial reasons. Full license, full support, amazing support, full documentation. So that started me off. So my something else was I wanted to discover whether ChatGPT had got it right or not. And it won't be any surprise to you to know that it hadn't. Its program was complete rubbish. So, before we get on to computing languages, let's look at some of the human languages that I have interacted with. Choose that word because don't go away and think, I can speak all those languages. The first four, Arabic, Italian, French, and Latin, I was having to learn at the age of 9. Why? Because I went to a large boys' mission school in Khartoum, Sudan. And they used 3 teaching languages: Arabic for the Arabic speakers, native language of the country; Italian for the commercial classes, because it was the commercial language of the country. I have no idea why Italian was a commercial language, but it was. And English for everybody else. And during my entire time there, in a school of 2,000 pupils, there were never more than 6 native English speakers. I know what it's like to be in a minority. And if whichever language you were being taught in, you had to do the other 2 as second and third languages. My Arabic was once described by a teacher as sounding like the last gasps of a dying man. However, I did remember enough Arabic so that many years later, as a young teacher, having to interview a Syrian student to discover what level of maths they had, and they couldn't speak any English, that I managed to, with diagrams, geometry, and all the rest of it, and knowing how the Arabic numerals actually work in Arabic rather than in Europe, allowed me to interact with that student and assess their mathematical level. French and Latin, well, I was being prepared to go back to a prep school in England when I was 11. So I was learning French from my mother, who was a fluent French speaker, and Latin from a private tutor. Let's move on to the languages individually, because each one of them taught me something. Arabic taught me the difficulties of pronunciation. If you want to test an Arab's fluency in European languages, ask him to say Battersea Park Station. He won't manage it. Because Arabic is a language in which there are only 2 kinds of syllables: consonant vowel and consonant vowel consonant. That's all. You cannot have 2 adjacent consonants. It doesn't have a letter. The letters B and P are just unified, like the letters L and R are unified in the Far East to a single sound. So Arabic taught me problems of pronunciation and some things that I have never mastered. How do you distinguish between a glossal stop? Glossal stop? Anybody know what a glossal stop is? Cockney English, bar. The gap in there is a glossal stop. The difficulty is that Arabic allows a glossal stop to be the first consonant of a word. Worse, it's got a semi-glottal stop. I doubt that I could tell the difference between a glottal and a semi-glottal, but they can. Anyway, so Arabic taught me this thing about the enunciation of languages and the possible confusion. It also taught me another thing. It's not an Indo-European language. It's a Semitic language, like Hebrew. And that has a lot of consequences. And one of them is that the consonants carry the meaning. The vowels just qualified. That's why they leave the vowels out most of the time. Interesting idea. Moving on. Italian. Do you know, I've completely forgotten all the Italian. Even 5 or 6 years later when I was on holiday in Italy. No Italian left. So what does Italian teach me? Well, it's very easy to forget a language if you don't have any motive for remembering it. French, curious. People think of French as being just a sort of another sort of English. Well, it's interesting because French and English are both Indo-European languages. They have a similar sort of general structure until you realize that in English, our simple sentence is subject-verb or subject-verb-object. And in French, the verb comes third. For simple sentences, subject, object, and verb, that gives you, in fact, if you think about it, 6 different orderings. And to my amazement, there is a language somewhere in the world which uses each of those orderings. There are languages that put the verb first. There are languages that put the object first. So anyway, French. French taught me something many years later, is that in extremis, when you're desperate, your memory can be your savior. I was in Belgium, went for a walk from the hotel. I had a plane to catch later that day and got lost in a French-speaking city with these proud Belgians who wouldn't possibly admit to being able to speak English. And I managed to rescue enough of my school French to actually hold a conversation asking for help and guidance to the hotel. So I did catch the plane all right. Latin. Well, the thing which I noted about Latin is there are an awful lot of words for battles and fighting. And by contrast, going back, in Arabic, there are an awful lot of words for gardens. Arabic has at least 7 words for gardens, one of them specifically the Garden of Eden. And this is an interesting thing, that some languages seem to have some focus. Now, it may be that the Latin is because the surviving works which one's taught in school are things like Caesar's book on his various episodes. Classical Greek, I think I was 12 when I was exposed to classical Greek. And there's an interesting thing. You have a language which actually doesn't have singular and plural, but has a dual in the middle. You had a language which was written in a different alphabet. Well, that was true of Arabic as well. I don't know much about my classical Greek. I managed to forget most of it. But Chinese. No, I never learned Chinese. But I needed to be able to read Chinese characters. Because 2 of my things, my major sport when I was at university was judo, and my major intellectual game is Go. Both of them Japanese-based these days. Go is Chinese in origin. And all the authoritative texts for Go at the time I was learning it were in Japanese, and Japanese writes largely in Chinese script. Now, the problems that would be presented were fine because it would be a Go board and the moves would be numbered in, surprisingly, European numbers, not Japanese numbers. I don't know why, but they were. But it's rather important when you've got a thing which is a problem to solve that you should know what the problem is. And that meant I had to be able to follow the text. can't speak a word of Japanese, can't speak a word of Chinese. And anyway, which Chinese? And what Chinese showed me was that alphabetic languages are not the be-all and end-all. Character-based languages have a great advantage. They are independent of the way you pronounce them. The symbols are not directly connected with the sounds. It also taught me about the bias some people have of the belief that you couldn't possibly have a Chinese dictionary. Because what order do you put them in? Well, I've got 2 Chinese dictionaries sitting on my bookshelf, so obviously you can. And the answer is, the secret is you count the number of strokes. Every character, you count the number of strokes that make it up. Can be anything from 1 to 17. And you identify the thing called the master stroke. And there are a whole lot of possible master strokes, but they're a fairly finite set. When you've identified the master stroke, you go to that part of the dictionary and go down to the section for that number of strokes. And you'll be faced with perhaps 3 or 4 characters that match. So it's perfectly possible to have dictionaries for non-alphabetic languages. Also, another thing from non-alphabetic languages is it exposes this fallacy that it doesn't matter what language you speak, you can have the same sort of ideas. I challenge any of you to come up with a Chinese crossword. On the other hand, Chinese is a language, or all versions of Chinese, Mandarin and so on, are phoneme deficient. They have a very limited number of sounds. And that makes them beautiful languages for puns. Fortunately, English is not bad for puns, but there are other languages in which puns are almost impossible. And incidentally, those people who like to think about this beautiful machine language translation, machines cannot translate puns because puns don't translate. So the next time you hear somebody talk about how good it will be, just remember they don't manage everything. Japanese, well, I've already sort of alluded to that, except one of the interesting things about Japanese is the concept of annotating a word. If you look at a piece of Japanese, you'll sometimes find that Japanese much prefer to write in characters rather than in one of their 2 scripts. You'll find across the top of a character a set of Japanese syllables. It's an annotation, a qualification. One of the delights I had when we got to word processors and so on is the ability to split a line. You know, you're finished up with a concept which is either that or that. You know, it's a sort of halfway in between 2 things. Well, why not write them both, one above the other, and leave the reader to pick? And finally, my favorite. Has anybody here read Don't Sleep, There Are Snakes? One of you. Fantastic read. Basically, the author, Daniel Everett, was a Christian missionary who was also a linguist. And he went as a missionary to a small Amazonian tribe, about 350 people in it, the Baraha, who also speak a language called Baraha. The difficulty with Baraha is that it has no mechanism for talking about third-hand experience. I can tell you what I saw yesterday, and you will believe me because that's what I saw. I'm attesting to the fact I saw that. But you can't tell your wife or your husband or your children that Francis saw a cat yesterday. There is no mechanism in the language for that. The upshot of that is it's a language which you cannot have history. It broke Daniel Everett's faith because he couldn't translate the Bible. Despite years of trying, he couldn't communicate the Bible to this tribe. It's a tiny language. It's a language in which there's been a large amount of argument, but it's interesting. And Tom Wolfe wrote a little bit more about the whole episode in Kingdom of Speech. I'm not enamored with Tom Wolfe's writing. Very, he tends to have a very dogmatic personal view. For example, who developed the theory of evolution? Well, we know in actual fact there were two people, but the way he contrasts them sort of makes it look as if somebody was taking a class advantage. But Don't Sleep, There Are Snakes is well worth reading. Artificial languages. Esperanto. Yeah, I did study Esperanto at one time. It's based on a completely false idea because it really takes not only Indo-European, but European languages and tries to create a generalized form. And it's great if you talk Romanian to translate, and you need to translate it into Ukrainian. If you don't have somebody who speaks both, how do you do it? And the answer is you translate the Romanian into Esperanto, and the Esperanto gets translated into Ukrainian. But it actually doesn't generalize to the world as a whole. So that's what I take away from Esperanto. Lochlan, how many people have heard of either of those? Good. Lochlan was invented originally to test the hypothesis that what you speak controls what you think. And it's a language which is supposed to be culturally neutral. It doesn't matter whether you pronounce J the way we do in English or the way you do in France. It has 5 vowels. It doesn't matter which particular accent you use for those vowels. It doesn't matter. Interesting feature, though, of Logline. It shows how focused academics can be. It was 10 years before somebody realized that they had no way of referring to those basic human functions. Piss, shit, fuck. No way of doing it. Of course, the language is based, again, on a more Semitic version. You have a root word which can be modified according to a set of rules. So they'd only got to introduce 3 new words into the language. But 10 years before they realized that they were deficient in being able to talk about ordinary ordinary human behavior. Lojban is a result of copyright problems. The original authors of Logline held the intellectual property rights, And it was difficult because a group of other people wanted to do a rather different development. But that's the origin of those. And it's claimed that you can't tell lies in logland, being a purely logical language. And that's a mistake. Of course you can tell lies. You can deceive people. Just because you have to say what you mean doesn't mean that you mean what you say. The last one, many different dialects. Sign. Why do we think that sign is a language for the deaf and dumb? It's a much more extensive language. In this country, and I think in most countries, they get it wrong when they talk about teaching a second language in their schools. Sign should be the second language for everyone. Why? Because there are so many instances where you, as an ordinary person, would benefit by being able to communicate with your hands instead of with your voice. Noisy environments, engineering environments, being able to talk to somebody across a crowded room at a party. Sign is a valuable, powerful language, and if everybody could at least speak one dialect of sign, they would benefit. And what's more, they would be able to see the benefit. Why do we teach French in English schools? Anybody know the answer? Because there are French teachers. One of my local schools in Abingdon used to run Chinese A-level for Mandarin Chinese. They had to abandon the course because they couldn't find anybody who could teach it. So often what we do in schools isn't governed by what is best practice, best in the interest of the students, but what manpower you or person power you have available to you. So, moving on to what the talk is really about, computer language types, computer languages. Well, we roughly can divide them into low level and high level. Arbitrary division line. It's a continuum and not a binary choice, but the binary choice works fairly well for some purposes. I have written programs in all four of those languages. The very first low-level language I learned was IBM 1130, assembler code. Oh boy, for the young ones in here, you have no idea what a challenge writing programs for a machine which has got a massive 8K of 16-bit words. And what's more, it's got a Winchester drive, which is sort of an ancestor of hard drives. The difficulty was, I had just done the only course I have ever done, learning Fortran. We'll come to that in a moment. But the upshot was, several of us had just got hold of Dr. Conway's Game of Life. And we thought, well, we'd like to program that. The difficulty is that in 8K of 16-bit words, you're pushed. And what's more, no visual displays, the only output is to a line printer. So I got hold of a book on IBM 1130 and taught myself that. Learned about, I couldn't do the input and output in assembler, so I had to use Fortran for that. But the IBM 1130 had the ability to page in an entire new section. And so we had this whole area of common from Fortran, which was the data, and the actual program side of it was paged through Fortran for the input, then the main thing, and Fortran for the output. And how did I switch? Because I could read the console. Now that's something that you don't do these days, of actually flicking a switch to communicate to your program. It was an interesting exercise, and by the time I had finished, I had one word to spare. Now imagine the problem of debugging. When your program occupies 99.99% of the available resources. And what would happen was I'd start the program running, and I'd watch the console lights. And when they started going, obviously in a loop, the program had got stuck, so I then asked for a core dump. And that was an experience because on a line printer, there are these spinning wheels and hammers, and the hammer hammers the paper onto the wheel when the wheel is in the right place. Now, if you take a core dump, you'll get some cases which are all zeros. A complete line, 128 zeros. 128 hammers hit the paper at the same time. The floor shakes. Fun. CECL. CECL stands for Computer Education in Schools Introductory Language. And it was the thing which, when we first were introducing computing into schools in the late 1970s, it was what we used to teach the basics. Here is the entire CECL language. I/O, in, out, line, and print. O, it's a language in which you have an accumulator, one accumulator, and everything is done through the accumulator. So in would be to take data from outside the program into the accumulator, and out would be take what's in the accumulator and send it out. Line allowed you to have some control over the output, and print message allowed you to print a message. Memory use, you could store to a location, or you could load from a location. Mathematical instructions, add, subtract, multiply, and divide, and in each case you can either use a constant or a location. So if I wanted to add 3 to 5, I would have put 3 in to the accumulator, and then I could write add 5. And finally, program control, jump, unconditional jump to a labeled address, jump if negative, jump if 0, and finally, the all-important halt to stop your program. Now, what that language taught me, or surprised me, was if you put this in front of a group of intelligent children, they can do absolutely unbelievable things with it. I'm not going into all the details, but I had a Jewish student who was only with me for a year, and for his coursework, he needed to provide 5 pieces, at least one in a high-level language and at least one in a low-level language. In other words, at least one in CECL, at least one in BASIC. And come Easter, he'd got lots of stuff written in CECL, fine, but he needed a high-level thing. So I gave him one of my takeaway problems, a palindromic number problem. Take any number, reverse it, add. If it's a palindrome, stop, If not, repeat. Now, in those days, without intense computer analysis, nobody knew any number that halted after 32 reversals. Either finished after 32 reversals or nobody knew how long it would go on for. What is it, and what's fun about this is a problem which is dependent upon what base you're writing in. So my thing is, write me a program which will take a number in a specified base and determine how many reversals were needed to turn out a palindrome and stop if you haven't succeeded after a certain number. Not base 10, any base. Well, we limited it up to, for this particular case, up to base 10. It was intended to be written in BASIC. At the end of the Easter holidays, Gad came back and presented me with the solution written in Cecil. I couldn't have done it, and I doubted many of you could do it. Think of the problems you have to, working in Cecil's base assumes you're working in base 10. Absolutely phenomenal piece of work. And it showed that the biggest limitation in solving problems is not the language you use, but the brain you've got, your own insights. Plan. That's an ICL 1900 series machine assembler language. And I wanted to take Cecil and arrange it was no longer batch processed. My students had access to the local polytechnic, now a university, but then polytechnic, had access to the computing facilities. And they had teletype machines. The difficulty is that Cecil was essentially batch processed. So they'd have to kind of write all this out, hand it in, with a bit of luck, 24 hours later, the machine room would provide them the result, normally full of errors. So I wanted to provide an interactive system. So summer holidays comes along. I get the school to buy me a set of plan manuals, work through this and write a program to interactively work with Cecil. And also added in a couple of secret extras like an array for facility. I can't remember I put an if then else in, but anyway, I added a little bit which was trapdoored. Students would only have access to this if they proved good enough to need it. That was a real experience. I only ever wrote one program in Plan, and that was this Cecil system. When I finished it, towards the end of the summer holidays, punched up all the cards, had it into the machine room, came back 24 hours later to have the machine operator, who was a great friend, in fact, come out with a whole box of fanfold paper. I think there are 400 sheets in a box. And he said, "These are the first of your error messages." We chose not to put another box of paper in for the rest. Yeah, more error messages in one program, I think, than I have had almost in all the other programs I've ever written. And the fundamental thing was that I hadn't understood that in a 1900 series machine, the 8 accumulators were different. The first 4 had a different set of instructions than the second 4. So I had to teach for the next term, and come around the Christmas holidays, rewrite everything. And I can remember January the 3rd. Can't remember what year it was. Sometime in the late 70s. I sat down to test the program, pushing it to its limits in every direction. You know, how many instructions were allowed in the program? The language specifies 200, and I'd worked for 500. How many different labels would you have, and so on? And literally spent 2 hours inputting stuff that would actually demonstrate that it failed safe in every resource failure. It was then used by my own students for some time, and I never wrote another line of plan. Set 80. Yeah. The school was going to have a 380Z research machine based on a Z80 chip. They're currently sort of fairly in the same time frame. Sinclair had produced a Spectrum, and I wanted a language which my students could run on a machine at home, which they could afford to buy out of their pocket money, because I was working in a school which was very divisive in the sense that half the students came from academic households and the other half came from the university servants' households. Very different backgrounds, very different financial resources, priorities. So it was very important to me that we did not waste stuff on the BBC machine, because that would just have created an elitist class and half the students would be completely disenfranchised. So I learned Z80 to write forth. Interesting experience, because I had my own 380Z, which had a floppy disk drive, no hard drive, no compiler, no interpreter, just an ability with a front panel of being able to type the stuff in for myself. So I had to become my own interpreter, became very fluent at calculating stuff in hexadecimal. And it was an interesting experience. That was the last time I actually spent any time on assembler languages. What did I learn from assembler languages? It's hard work. It's easy to get things wrong. You need to be very persistent. You need to really, really, really want to do whatever it is you're doing. I incidentally also used Z80 on the Research Machines 380Z to enhance Research Machines Basic, added in 30 new commands to do list processing. But that's another story. During my life, I have interacted with these languages. Notice the term interacted. That doesn't mean I actually ever wrote a successful program. Fortran 4 was the language which I did for an evening course at the Polytechnic. I thought, well, I'm very interested in learning some programming. The tutor for the course was a nutcase. First of all, he believed that Fortran should always be written in free format. No, not the strict Fortran formatting, but the free form of it. The second thing is that he was a campanologist, bell ringer. And he believed that the most exciting, motivating thing you could do to write a program to work out the changes on a carrion of bells. And it never crossed his mind that none of his students found this in any way exciting. So that's Practice problems are personal, something I took into my teaching. Do not tell a student this is the program you're going to write. If it's a piece of coursework. Try to discover from them what they're interested in. And then the student who said, oh, I want to teach you to play chess. You then had to say, well, actually, I think that goes a bit far. Can we start with something simpler, like take a chessboard, put a knight on it somewhere, and work out which squares it can get to? Because young people's ambitions can be somewhat extreme. But the important thing is, if you're going to ask somebody to dedicate a considerable amount of their personal time learning something, make it something they want to do. And then they will do it remarkably effectively. Avoid extensions. Oh, this was a terrible thing. I forgot one thing. I'd got this whole thing written. Forgot which machine it was. Must have been the IBM 1130 that I had got something written entirely in Fortran, IBM Fortran. And I completely ignored the fact that, or probably unaware of the fact that IBM had all sorts of extensions. You could do character processing, which wasn't part of the original Fortran. So the Polytechnic got rid of its IBM 1130 and gets a, which was only on hard anyway, and gets some ICO 1900 series machine. And that was a Fortran which was by the book. And I had this whole pack of cards with my Fortran program, whatever it was it was supposed to be doing, and none of it would work because a lot intensely character processing. And so I gave the project up. I couldn't be bothered to go and rewrite it. It was a bad experience in that sense. If you are going to write something, if you write something once, just for today, doesn't matter. Use any extensions you like. But if you write something which you expect to be able to use next year on a different machine, look at the standards. They're important. They really are. And it's one of the things I would, if I could go back in with a time machine, it's one of the things I would tell myself. Basic. Much derided. I've lost count of how many dialects of Basic I learned, each with its own little twists, for loops, and so on, were not quite the same from one to another. Interpreted or compiled. The English flagship, the BBC machine, used an interpreted Basic and boasted about how fast it was. Well, yes, for an interpreted version, it was quite fast. But compared with the compiled versions running on CPM machines, it was pathetic. So there was a thing that I learned fairly early on, was the difference between running something interpreted and something compiled. Many little programs sharing an ad hoc data structure. I was commissioned to run the results center for the English National Schools annual regatta, and that's a 7-day event. Multiple races which would have embedded in them separate groups within the same race. So I sat down and constructed, well, first of all, I bought a very cheap CPM machine. And I constructed a data structure. I won't call it a database, a data structure. And then operated on this data structure with little programs. The first 3 lines of each program would be boilerplate, which basically described to the program what the data structure was. And the next 7 or 8 lines would do whatever it was. It was an interesting exercise and worked surprisingly efficiently. I can remember on the second day, one of the race organisers coming in and said, "We've discovered that we've got 7 boats in whatever class it was, in the handicap races. Can you take those out and create a separate set of results for that sub-fleet?" How long did it take? I said, "Come back in 20 minutes. And the results were there in 20 minutes. Because the mechanism of an idea of writing little programs to operate on a data structure. And finally, in my experiences with BASIC is super basic. Anybody come across super basic? Fabulous language, multitasking. In fact, to do I/O from a QL, you needed 5 programs interacting. So it was an interesting experience. It was also interesting because it was believed that it was not compilable until somebody actually produced a compiler for it. You can still play around with it today. It's an interesting variant on BASIC. Fourth, first time I had a language which I was in control of. This is the language I wanted for my students. People thought I was a nutcase. Probably was. But this is what the language I taught my students. It's their first high-level language. Once I got past the basic stage. And I had a version of Forth, written by myself, which ran on both a Spectrum and a Research Machine 380Z, completely compatible. And the geography teacher was a friend of mine, had written me a hardware link from the Spectrum to or provided the hardware for linking a Spectrum to a 380Z. And I sat down and worked out a protocol which allowed me to move data between the two. And so a student could do his homework on his home Spectrum, come into school, plug the Spectrum into the school's 380Z, transfer the whole lot across, and it would then run on the 380Z. Interesting exercise in portability. However, the thing that caused most of my colleagues to think I was completely mad was that Forth uses reverse Polish notation. No brackets, no priorities with your operators, no operator precedence. And they said, "You're crazy. They screw their brains up." No, if you're under 20, it's not a problem. I used to say to them, well, the example I gave you, you're going to paint a room, what do? You get the paint, you get the brushes, you get all the tools together, and when you've got them all together, you get on and do the job. And there you are, reverse Polish decorating. So, that opened up to me the fact that adults have very often got their brains frozen down to their perception as to what it ought to be. Reverse Polish notation, which was used on the Hewlett-Packard hand calculators, is a problem for adults, but not for children. Readability is not a language problem. I had given my first-year computing studies students their first piece of coursework, which went like this. Working in 2s or 3s, no singletons, no groups larger than 3, I want you to provide me a program for educational use by a child in the age range 5 to 11. That's it. I had some marvelous results produced. But one of them was the one where the two concerned had produced a very simple program to do single-figure number bonds. 3 plus 5, 8. Nothing particular about that. Until you realize that they'd actually thought about the person who was doing it. The first problem is they're not going to like little letters, typical thing on the screen. So they'd use the graphics facility I had provided and realized they could use this to magnify the thing so that you've got big numbers. The whole of the video screen was 3 plus 5 equals. The next thing is, how much do you think a 5-year-old is going to get to pressing the answer and then return key? No, you need a raw keyboard read. They've got that. And the last element was the motivator. What 5-year-old is going to sit there and do it for just do it? They had a little railway engine that started at the left-hand side of the screen, and every time you got the right answer, the thing chugged one station. Smoke rings. Pistons. If you got the answer wrong, it chugged back one station. And finally, when you got through all the 10 stations, it went into the railway shed, and a little man comes out and waves at you. That was the first program those two children had ever written. So I was showing this to one of my colleagues from another school, and he said, "Oh, that's fantastic. Can I see the source code?" I said, "Yes, but you won't understand it. It's all written in Forth." But anyway, here it is. He said, "That's not a problem. I can read it." And the whole point was that the children had chosen variable names and effectively function names so that the thing actually read engine, pistons go, smoke ring, and so on. You could read it. The language might not seem to be particularly conducive to clear writing, but it can. Unutterable names. How many of you know what an unutterable name is? When I had done my conversion of Forth to run on, which I started with the Forth interest group Forth and then seriously modified it in lots and lots of ways. But there was one small element. Forth has a tree of words, and they have junctions where vocabulary springs off. And every node has a name. But it's very important that nobody can name the junction node, because that could pull the entire system down. Yes, you can redefine plus to do something quite different, but you don't want to be able to. And all I knew was that there was this thing in the structure that if I changed it, the system didn't work. And it was 18 months later that I came to realize that 0A, 01 means one blank. Because the structure of Forth names is a string of characters followed by how many characters there are in the full thing. So you could, it allowed you to use just the first 3 or 4 letters of a variable name and have arbitrary other letters if you wanted. It was a way of condensing your data. But it was, I can remember still when the bulb went up in my head. Of course, that's a blank space. And you can't type a blank space as the name of something. It's unutterable. So unutterable names, important features in some aspects. Beware of authors who lack understanding. Yeah, Awful lot of books written on Forth, and most of them were trivial, and most of them didn't understand the language. Pascal. Nanny languages. Whole generation of people went to university, and this relates to what Herb was talking about earlier on today. They came out with Pascal. And the point about Pascal was, it was supposed to protect you, supposed to stop you making idiot mistakes. The difficulty was the level of protection meant that it wouldn't allow you to do things that the intelligent programmer knew you could do. So it created two groups of people. Those who trusted the compiler. If the compiler will compile it, it must be okay. And another group of people who think, forget what the language is stopping me doing, I'll find a way of doing it. And the most dramatic example of that is Donald Knuth's Metafont and his other, his general software. In those days, his programs needed initialization. And the initialization data took over half an hour to initialize on startup. And he needed a way in which you could initialize once, and that was it. And the only way that he could do it would be to create a core dump which could be reloaded and restarted. So he introduced a thing which he called a crash switch. Single binary variable. If it's true, you've been initialized. Get on with it. If it is false, this was the first initialization, crash so that we get a core dump. One of the few cases I know of a programmer who wrote a program deliberately to crash it. Not sure of the later iterations of it. So hacking to achieve objectives. Think of that tranche of students coming out into the real world, which wasn't using Pascal. It was using C. So what do? Get hold of Koenig and Ritchie. Quickly read it. I told your employer I can do it, but now you have to. And the difficulty is that if you read the C programming language, it doesn't mention lint anywhere. It doesn't mention the tools. It just talks about the language. It assumes you're using a Unix system and you understand what you're doing. And so you've got this group of people who complain about all sorts of things, C multiple units and unspecified behaviors and so on. And an awful lot of really, really bad C was written because people were taught Pascal. Well, that's my belief anyway. Dangers of ignorance. Trusting your compiler. Oh boy. There's so much stuff out there. Not knowing your tools. It's important to know about things like lint. Of course, these days we have sanitizers and have a whole lot of other things. But back in the 1980s, the world was a simpler place. And learn about implementation-defined features, because they can take a program that works perfectly on your machine and completely fails on someone else's. When Herb was talking about the overlap between C and C++, I thought, actually, there is another group of programs that compile as C and compile as C++, but do different things. Because there are one or two features that are not transferable. The size of a character used to be, I don't know if it's still true, but the size of a character used to be important. Haskell. Haskell taught me what pure functions were. Quite important because C++ programmers, template metaprogramming and so on is strongly related to functional programming. Avoiding side effects. One of the biggest problems with not just C++, but with most high-level languages is the side effects of your work. You don't have a mechanism to say, this function mustn't have side effects. I know we explored it in WG21, but decided that the cost was too high. On the other hand, side effects are necessary. You can't do I/O without, because I/O is a side effect of whatever you're doing. So you do need some side effects. Prolog, oh boy, if you've ever come across Prolog, you really have to bend your mind to an entirely different view of programming. And I'm not going to say anything more about that one. Lisp, I struggled with Lisp. I really struggled. It uses Polish notation, incidentally, or pseudo, because you can put the operator first and then you want to add 20 numbers together, bracket plus the numbers of the list, close bracket. In other words, it doesn't use the normal format we use for arithmetic. The idea that programming instructions are just data. That's all they are. It's a new way of thinking, and I must admit, I never really mastered it. I keep on thinking, I really must go back and have another go. Because I know lots of people, probably lots of people here, can work with languages like this fluently. Logo. Logo is a great sadness. Total graphics took fire across the world. And very, very few people ever got beyond the total graphics. Apart from anything else, because largely teachers didn't understand it. So the sad thing about Logo is a number of places that people simply stopped. They did the total graphics. Great. But you can do total graphics in any language. Well, any language which supports graphics or control systems. Scratch. How many of you are familiar with Scratch? Good. Scratch is extraordinary, and it's an example of how teachers must stop teaching. Teach your children the basic rules, and then let them go. Because the way Scratch allows young to explore their imaginations is fantastic. But you mustn't have a teacher say, oh, that's not how you do it. If it works, that's the way you do it. You may say, perhaps it would do better like this, you have some input, but there is a great tendency to over-teach. C++, what's this thing about the ignorance of experts? I was appalled during the 1990s at the number of people speaking at conferences who clearly didn't know what the language was. They had a C perspective, and that's it. It took years. It took years to get the two into ISO standard groups, even talking to each other. we had, I forgot which country it was in, but we had one time when we had arranged back-to-back WG14, WG21 meetings with a joint reception. And it was tragic. All the members of WG14 got together in their own little group, and all the members of WG21 got together in their group, and never the twain shall mix. We did manage to improve things over the years, but this, anyway, the ignorance of experts. Multiple paradigms are difficult to combine. And the difficulty is you've got a language which supports a lot of paradigms, which C++ does. People, they sort of fade into each other. People don't switch particularly well. They don't seem to really know which one they're doing. But that's what makes C++ a difficult language. Finally, where it all started, APL. APL stands for A Programming Language. It was developed, I don't know, 70s, 80s. Wasn't terribly popular at that time, apart from among mathematicians, because it used all sorts of arcane symbols which weren't on your keyboard. The world's changed nowadays. Those arcane symbols are all in Unicode, and it's a doddle to remap your keyboard. But breaking the loop habit, we think of all, you write your program. How many of your programs don't have any loops in them? Any explicit loops in them? You see? And yet, good APL programs, and we're going to have one in a moment, don't have loops in them, not explicit ones. Of course, deep down under the covers, there are iterations going on, but they're deep down under the covers. Matching the language to the problem. APL is an array-based language. There are only two types of object in APL. Standalone objects and arrays. And you know, APL allows you an array of 0 dimensions. Of course, it's got 0 dimensions, so it's got nothing in it. But you need to be able to distinguish 0 as a number and completely empty. Well, there's nothing there. It can't. Empty suggests that you could put something in it. But it's a null array. It's what's outside the universe. And pictograms go back to the Chinese. Pictograms are useful. They allow you to condense stuff. Well-chosen pictograms will help communicate what's going on and have some advantages over alphabets. Finally, I want to spend some time looking at an APL implementation of life to try and let you see how an array view of life, didn't mean it like that, an array view, if it matches the problem, makes things very simple. Dr. Conway's game of life is an array-based thing. It's about a 2-dimensional array. Incidentally, APL will handle arrays up to 16, 17, 18 dimensions. How many dimensions depends upon how many dimensions the implementer is allowed. So, with life, there are two things you want to do. You want to take an array of bits, noughts and ones, and from that you want to generate the next generation according to a set of rules. And when you've done that, you would want to display it. So, Let's have a look at these things. There is a function to generate the next. Let me walk you through this one. Let's take the top. Generate, good name. Ignore. APL has, all APL functions either have no arguments, one argument which comes after it, or two arguments, one on the left and one on the right. Those are the only formats for functions in APL. Why ignore? Well, because actually this is going to be, it's going to be used where necessarily the thing calling generate is going to provide it with an argument which you have no use for. Now, semicolon T1, semicolon T2, and so on, those declare your local variables. If you use a variable without having annotated it as being local, it is automatically global. So, U1, now note the arrow. The arrow is an assignment. Much more. The difference between equals, which is a logical operation, and assignment, which is to put something in. So what does it do? It says, wow, what's that weird character with a line through it? Well, it actually says, take your array and move the two-dimensional array, move the line on the right over to the left. Rotating, if you like, right to left. Well, the one says just one line across. So there you have, take your universe. It's a global variable because it wasn't listed anywhere else. It's a global variable. Take your universe and shift what's at one end across to the other. Then add it on to the universe. And APL very sensibly said, what do you mean when you add two arrays together? You add the elements. And now, don't miss that thing called a high minus. APL distinguishes between minus as a qualifier, negative, and minus is an operation. The ordinary minus is an operation. A high minus says this is -1. And all -1 does is says, instead of rotating it that way, do it the opposite way. So what you basically have out of that line there is to take your initial universe and then replace it so that each element of the new version is the sum of the thing which was there originally and the two objects on either side. You with me with that? Okay. So that's done that one. And now U2, local variable. It says, take what you've done up there and this time rotate it the other way. Instead of side to side, top to bottom. Slightly different symbol, but it has this feeling. And I can understand what's happening because the symbol relates to the operation. And do very similarly to what you did before, but if you do the maths, you'll find now that each element of U2 will be the sum of the original and the 8 numbers rounded. The 8 kings move away. Now, in your universe, That's an array of unspecified size. Multiply it by a new array, and just like for addition, multiplying two arrays together says multiply the corresponding elements of the array you get from U2 compared with 4. And so what it now happens is it goes through, and every time in U2 it finds a number 4, it fills in a 1. True. Everywhere else will be 0. So now your new array has 1s replacing all the 4s and 0s everywhere else. And the end result of that is that T1 is an array whose elements are all the ones of the original that have either were alive and have 3 neighbors, or have four neighbors. Now do a similar comparison. What did I say? I've got that last line wrong. If the number is 4, it's either because the thing was alive and it's got 3 neighbors, which under Conway's game of life means it will live next time, or it was not alive. Sorry. It works. I mean, yeah. Similar thing for things that have got 3 in them. Add the 2 versions together, and you now find what all the live things are. And the final 2 lines here basically say, this says, display it, we'll see that about the display in a moment, and save it, update. And that does the complete generation. Displaying it. Right, function called display. Display your world. That's your argument. Convert your global variable universe, so it now contains world. This pieces here, I don't want to go into these. They are provided by dialogue. They are the things that allow me to interface to a window and do the graphical work. In very simple terms, this one says, create me a bitmap from the input and display it. And this next one says, using the bitmap there, event mouse move, if the mouse moves, call generate. So that's your callback function. And that's why the generate uses the callback function has to have this completely ignored argument. Because when you use a callback, the callback system from Windows will provide you with an argument, which needs just to be ignored. And second callback, if you press a button, which you're going to caption what's next, the event is, again, generate and put the button up, coordinates, node. But those aren't APL, those are just the graphics features provided by dialogue. So does it work? Well, one of the advantages of working this way is that if you wanted to change the rules, supposing you decide that you wanted things to be alive if they've got 8 neighbors, you know, overcrowding, okay. Just one extra case of life. Then all you have to do is write in one extra line there, the thing has 8 neighbours. The result of the earlier arithmetic up here will be to create 9. Any 9 in that array will be something which was alive originally and has 8 neighbours. And that would give you a T3, which you would have to add in as well. In other words, you can play around with the rules very easily. And if you don't believe me, remember that I'm not going to see 80 again. And I managed to get my mind around this, and I managed to get it to work. Now, finally, let me go back to something I had done earlier. Let's large glider factory, okay. Whoops, made that same mistake earlier on. Auto-completion doesn't work unless you actually do the auto-completion. Right. Let's blow it up to full size. There's your button next up the top there. So if I want to single step through the generations, I just have to press. Can you see on the screen what's? I'm sorry, I can't magnify this one as it is. Or because it's watching the mouse, if I move the mouse around, remember the mouse move, every time it spots a mouse moving, it generates. And you can see actually it's working reasonably effective. I think that was a universe of about 1,000 by 1,000. In other words, there are 1 million elements in there. Let's try one of the others. You know, I never know how much people actually know about the elements, like, no, not life, what do I want? That's a very complicated life object that moves along the screen. The interesting feature of this particular program to run life is that the thing wraps. It deals with the boundary problem simply by producing a finite universe in which the top wraps to the bottom and the sides wrap round. So the thing wraps, which means that instead of the puffer train going on forever, it collides with its own trail. Right, that's all I have for you. I'll take questions. I warn you, my hearing is very bad, but I'll take questions if there's anybody who wants.
You challenged us at the very beginning with this addition
and... yes!
But you...
Some answers and some reasons. Okay, yes, well asked. Let me get back to... just bear with me for a moment. No, go away. As a slideshow. Right, so there are the questions. And now let me explain to you the answers, or how the answers arrive. First of all, APL works right to left. Secondly, it has no precedence for operators. So that first line says, multiply 5 by 3, 15, add 2, 17. That one you might well have got right if you use precedence. The second one, most of you think a star means multiply. Well, not in APL, a star is an exponentiation function. So that says raise 3 to the power of 5, and then add 2. 3 to the power of 5. 3, 9, 27, 81, 243, plus 2, 245. Again, APL uses real mathematical signs that you would have learned in school. So this one looks like 3 times 5 plus 2. No, it isn't. It's 2 plus 5 is 7 times 3, 21. No operator precedence. This one here, 2 plus 5, 7, raise 3 to the power of 7. Whatever that comes to be. Something fairly large. And then last one down here, this is the one which I think is quite interesting, because you think of this symbol here as being divide. In APL, it's a replicate symbol. It says, this particular version of it, it'd be different if there was an array here, but this particular version says, replicate 2 5 times. It gives you 2, 2, 2, 2, 2, 5 2s. That's an array of 2s. It's an array of dimension 1. Add 3 onto an array. If you add a single thing onto an array, you add it onto every element. So that says add 3 to each of these 5 2s and gives you 5 5s. Let's check. There you are. Yes, 3 to the 7th is 2,127. The reason for these questions is to try to show you, be very, very careful when you read something and think you understand it. Make sure you understand the context. And this is particularly dangerous when you're moving from one language to a very similar language. You look at something and you think, I know what that means. Actually, you don't. You only think you do. And that's a very dangerous situation to be in, particularly with languages that are very similar to each other, but have nuances. You know, languages in which have strict order of evaluation. Languages that do or do not use precedence, and so on. So that was the purpose of that exercise. I think most people would have got the 17 for the wrong reasons. And very few people would have got the last one, and that's the new APL. Right, any other questions?
Other questions?
You said at the beginning you'd asked ChatGPT or some similar large language model to write this code for you.
Sorry?
You said that you'd used ChatGPT to write this code for you. What was wrong with what it did?
No, you misunderstood that. I set an exercise for readers of CView to produce a program to do, it was some sort of word processing, and I took exactly the same text that I gave to the readers and fed it into ChatGPT and then said, but do it in APL. The readers can choose any language they like, but I specified it. In fact, I've tried ChatGPT with quite a number of different languages, and the only one which it refused even to try to do was Scratch. All the others that I could think of, Snowball and so on, it produced something almost certainly rubbish. In one or two of the better languages, it produced something which would work, but not efficiently. But it's a very salutary warning to people about ChatGPT. Just because it looks sensible doesn't mean it is. Right, any other questions?
I think we are at the end of our time. Thank you very much. Let's thank our speaker.